co-host this. It's my pleasure to co-host this program today. I'm Ejovi Ekakite, a master's student in data analytics technology in the University of Bolton. With me, it's Fumilayo, who will be co-hosting this session today. Okay, so today is the 6th day of this series of talks, November to Remember. It's been very exciting, very engaging, and very educative in the past 1 week. All right, and today we will be having an associate prof who will be dealing with the topic today, cracking the code. So we'll be looking into the nexus of dementia health and social impact. So Associate Prof today will be talking to us on how to crack the code of young adult dementia prediction, exploring for social impact. All right, so I would call on my co-host, Fumilayo, who would read the bio of Associate Prof. Dr. Vandana Sharma, and we'll welcome her today. Fumilayo, please.
Good evening, everyone. Welcome to today's series of November to Remember. It's our pleasure to have Dr. Vandana Sharma in our midst today. Dr. Vandana Sharma is an associate professor at Christ University, Delhi, India. Currently, she is a postdoctoral fellow at Lincoln University College, Malaysia. Dr. Sharma has 14 years of teaching experience at the postgraduate level and has expertise in subjects like data structure, algorithm, advanced computer network, and software testing. She has guided over 100 plus dissertations at the postgraduate level. Dr. Sharma has served NACC accredited A+ institutions like Galkotias University, Greater Noida Campus, Guru Gobind Singh University, Delhi. Dr. Sharma obtained a doctoral degree from AMT University, Noida Campus, with MTech and BCom from Guru Gobind Singh in Delhi. She is a senior member of the IEE and as a NIN researcher, she has published 35 plus research papers in SCI and Scopus indexed international journal and conferences. Dr. Sharma has contributed voluntarily as a reviewer and technical program committee member for reputed institutional journal and IEA conferences and has presented her work at IEA conferences across India and abroad. Her primary area of interest include artificial intelligence, machine learning, blockchain technology, and Internet of Things. It's our great pleasure to welcome Dr. Vandana Sharma to our midst this evening to talk to us about cracking the code. Dr. Sharma, you're welcome.
Yeah, but then hold on first. We'll have to call our head of school, Sam Johnson, to say a little thing before then. Thank you.
Thank you very much, Celestine. And I have to say, I'm fascinated by the sound of this topic. As many of you know, computer science isn't my specialism, but I can just echo Jovi's comments that the last week's sessions were just so informative, so fascinating. And we're really getting a sense of, we're getting insight into cutting edge research that's coming from all over the world. So the season's going extremely well so far, and as ever, it's a real privilege and pleasure for me to be here this evening supporting the series, and I'm really excited to hear Dr. Sharma's session. So welcome to all of our guests, but particularly to Dr. Sharma for joining us.
Welcome.
Thank you so much. Thank you so much for having me here, and namaste from India. I'm really glad to be part of the November to Remember series of talks, and I was really wanting to interact with people, and definitely I had a word with Professor Celestine regarding this, that please allow me, give me a platform where I can also talk about the area in which I'm working and I'm very excited about. So yes, thank you so much, University of Bolton, for hosting this event. inviting me. And I was talking to Professor Celestine that yes, we have a festive season here in India. So I could make it. I could make it at this time where India, at right now, it's 11:30 p.m. And in UK, it's 6 p.m. So I was able to make it that way. Thank you so much. Thank you so much. So I'll just start my presentation and a little brief about myself before that. So I hope my screen is visible to everyone.
Yes.
Wonderful. Okay, so I'll be talking about my latest work. I'm working on the problem of dementia, prediction of dementia, and what kind of social impact it has. So before moving to that, I would like to talk about who am I and from where do I come. So I am right now working as an associate professor with Christ University, Delhi NCR campus. And I have got 15 plus years of teaching experience and I'm still counting. I started my career in academia very early, at a very young age. And even now I'm like sailing through the boat. And currently I am having many technical books with me based on blockchain, AI, wireless communication with renowned publishers like Springer, Wiley, Elsevier, Taylor and Francis. Till now, I have got 60 plus SCI and Scopus indexed research papers. I have filed more than 10 Indian patents and published 10 Indian copyrights. And my main focus of research is artificial intelligence. This is the campus where I belong to. This is Christ University, Delhi, NCR. To little brief about like who am I and from where I come from. This is where you can see this is Delhi, capital of India, and we are here. So we are not very far off. We are very near, hardly 20 minutes away from this place, a very famous place, Red Fort in India. And these are some of the books I'm currently editing. So I will use this platform I'll take this opportunity to share the currently edited books which I'm working on. If anybody or if any of the researchers or faculty members, they want to contribute in one of the titles, they are more than welcome. So one of the title is Automated Machine Learning for Industry 4.5.0, then Technological Advancements in Electrical Vehicles. This is another book I'm editing currently. The call for chapters is open. And another book that I'm working on is AI for Next Generation Smart Wearable Systems. Also, I'm working on future of transportation, logistics, and disaster management with drones. This is an edited book with the Elsevier. And another topic, interesting topic again, the areas of AI, where all we can see the implementation of artificial intelligence. Another one is intelligent manufacturing, challenges, applications, and future trends. And call for chapters also open for AI-based mechatronic systems and smart solutions in industrial automation. So these are some of the books which I'm editing currently, and some of them are already in process. Some of them are being published. One more interesting title I have right now is from Metaverse for Sustainable Production. And this is going to be published by Wiley. And another is Graph Convolution Neural Networks for Computer Vision, Trends and Application. So again, I'm going to take this opportunity to invite everybody, whosoever is interested can please contribute, can contact me after this talk. Okay, now coming back to the topic. So here we are going to talk about dementia. Dementia is a prevalent brain disease. This is an area where many people are working, and the challenges and why I have started working on it last 2 years. The challenge was that how we can actually predict it in early stage rather than waiting for the symptoms to come up and waiting for the problems to occur to a stage that it cannot be reversed. So dementia is a disease which is very much prevalent and many people are affected. I'll show you the numbers. These are concerning numbers, huge ones.
We can hear you again.
You can hear me? I'm just
Okay.
sharing my slides.
Okay.
1 minute. Yes. Give me a moment. I'm just sharing the numbers here. What exactly the numbers are.
Yeah, put it on slideshow. I know you're using good systems. Yeah.
My screen is visible to everyone, I'm so sure.
Yeah, it's still not.
Yes, can you see the screen now?
Okay, okay. Make it, put it on, yeah.
Okay, so this was...
Increase it.
Yes, so, okay, 1 minute. Yes, is it visible now?
Yes, but okay, go on. No.
Okay, so this was the data which was concerning, and this is from Global Dementia Observatory, where we can see the numbers are increasing, and there are 35 indicators. There are total 35 indicators, which actually talks about that what is the dementia and what are the stages of dementia and how it is affecting. And this observatory is a collection of data on dementia from 62 countries. Currently, 55.2 million people are affected, and the deaths related to dementia is almost 65%. And this is the 7th cause of the death. So this is really concerning that why it is happening and how it is happening. And even after post-COVID, the numbers are increasing. So this was one concern. So that was the reason why I took this topic. And I wanted to know that how can we as a computer science, a computer applications, students and faculties can work on this problem, how we can make a prediction early as compared to making a prediction later on. Can you see my screen now?
No, can't.
Okay, I'm sharing it again.
Okay. Good.
Yeah, all right.
Okay, so that was one area, one data that I wanted to talk about. And now if you see the problem which can be taken care of, it can be taken care of with the help of AI. So how AI can help? AI can help in detecting dementia at early stage. Now, how it can be done? It can be done with the help of image segmentation. So images, we have images of patients who are either suffering from dementia or maybe not currently suffering from dementia. Maybe they are having a mild symptoms. They are having very mild symptoms, very severe symptoms, or they are actually completely are diagnosed with dementia. So these 4-5 stages of images we do have, and then we can use a classification model, we can apply regression, we can apply classifiers based on which we can identify early diagnosis of this brain disease. Now, the problem with the current area here is that the small data set which is available, the data set is not openly accessible. The images, the brain scans, it is mostly based on the brain scans, and it is not that widely available. So we need to see that, okay, from where we can get the data to make the predictions, to make the classification work for us. This is one thing. Now, the materials and methods which we have used in our work, it was related to the MRI images of various subjects. Those were a mixed group of whether they were suffering from dementia or not suffering from dementia, or you can say that they were on different stages of dementia. So once we can train our model based on this data set, then we can easily predict. Now, if there is a new case of dementia, maybe a patient which comes up for this kind of a problem, so we can identify whether that person is belonging to a category of very mild, or very severe case of dementia. So this was the data set that we have used. This is dementia Alzheimer data set, which was created. It was comprising of MRI scans, images, with different sets of or different stages of patients suffering from dementia. Splitting this data set into two, as we know that artificial intelligence model is going to first train the model, and then we're going to validate the sets. So for more ensuring accuracy and performance of the model, we have bifurcated it into training and validation sets. Then using image segmentation, the accuracy of the classification was used for the affected areas. Now, the proposed model, what was the model that was proposed? So initially we are training the model with the help of dementia progression technique. So how it was calculated for each patient, there was a mathematical model proposed. Each patient, we are going to see the number of MRI scans, and based on the number of visits that person goes through. Now, for each scan, and because dementia is a very progressive disease, so maybe today, if a person is not diagnosed with dementia, maybe later on after 6 months, or maybe after a year, maybe after 2 years, that person may be coming to a stage of very mild disease of dementia state. So this was taken like when the person is thinking or maybe suffering or maybe having a notion that, okay, he is having some kind of a loss of memory. That time the initial scans are taken. Then in that case, the MRI scans is kept in a data repository. And then later on, it is compared with the existing data sets. So the model talks about providing a platform where the dementia, other clinical tests which are being done. So nowadays in dementia detection, the blood tests are there. There are ways through which you can diagnose dementia with the help of other biomarkers. Along with those clinical studies and along with those clinical search and doctors, this model is also going to help. It is going to work parallelly to identify the detection of dementia at an early stage. So by keeping those MRIs, by keeping those mathematical model in place, keeping it in a data repository, running the training and testing data sets, and working on the model, definitely it can predict. So predicting was more important as compared to, because when we predict, okay, something can happen, then the preventive measures comes in place. So this was the model which was proposed, and there were 3 observation cycles which were run on the data set. The data set was tested on data set 2 and 3. Then it was trained on dataset 2, and then it was tested on datasets 1 and 3. And then the third observation cycle, we applied trained on dataset 3, tested on dataset 1 and 2. So it was, you can say, a kind of a mix taken, said that, okay, what is the probable results of taking one dataset as a trained and other two as a tested data set. So the accuracy which we observed was almost, it was observed very good. It was almost 90%, where we were having the images in a form of original raw images, which were gathered from MRIs, and the morphologically changed images on which this particular model was applied. So with the help of local post-hoc interpretable machine learning model for predicting dementia, we were able to see the high accuracy and performance of the enhanced images. So once we enhance images, we are in a position to identify the regions which are being affected with the help of progression of this particular disease. And the other advantage of having this kind of implementation was that it was accelerating the diagnosis process in digital healthcare. So once it is being implemented, the patient don't have to be there present in the clinic every time for any kind of diagnosis, because we know that when we are talking about, when we are dealing with the mental disease, or you can say the diseases that affect your brain, it is very difficult to handle such patients. So there was a need to have some automation, some kind of implementation where the scanned image, once the scan is done, okay, the prediction can be done at some other place, maybe remotely. So that kind of implementation was the idea, to implement this LP-IML model. And another thing that can be done in future was where we can implement wearables, smart wearables, to the patient. We can apply, or maybe we may give one particular device which can scan the body biomarkers along with the other biomarkers which are being scanned, maybe your heart rate, your pulse rate, your the oxygen levels. This is something which is in general being judged, or in general being captured. But along with this, we can also see the movement of a person who is affected from dementia, their location, their other biomarkers which are important, maybe the areas they are going, whether they are moving or not moving, that kind of indoor positioning system. If we try incorporating this model with the indoor positioning system for patients who are suffering for dementia, may improve their condition, may improve to an extent. So this was one important area where we worked on. And also in coming time, also in coming future also, this particular model is going to be compared with the other traditional models like SVM and other autoencoders to judge the performance of the proposed model. So this was another area which we were working. And yes, the future scope of, or any advancements that can be done in dementia is based on implementation of automated environment for dementia affected people. This can be one area where the research scholars or faculty members can work. So here we do not have any automated environment. We do not have places, or you can say where we can, maybe the home environment itself, we can make or accommodate for dementia affected people. They are very vulnerable. We need to understand the life cycle of them. So they are what I have observed from the data set, that they are active in their initial years. They are successful in their most of the life up to 50s or 40s. And then eventually, after some time, they are like degraded, the way they are talking or the way they are recalling and trying to recall certain events, or maybe they are vulnerable, they're trying to maybe recalling certain events is very difficult for them. So, and they need a homely environment. If you want to stop this disease, or we want this, the progression of disease must stop somewhere. So we need to give them an environment which is good enough and it is good as home. So that can be done only when we have some automated environment for dementia affected people within the vicinity, not in the hospital. It is very difficult to manage patients who are suffering from dementia. And for them, this can be the focus areas. Now, the 3 parameters which I have given here is, one can be when it is a home environment, we can give more accurate readings. We can get more accurate whether the patient is improving, not improving. This can be one thing. Another is we can provide privacy to the patient and also to the family, because when we talk about dementia, it is not only about a person, it is about the entire family. They are also affected. So for them, privacy. And then the third factor can be the cost effectiveness. So when we are applying AI for automated environments for dementia affected people, we need to see that, okay, we need to also see that it can be implemented worldwide, or it can be implemented on masses. So that masses is possible only when we generate, or we model, we come up with instruments which are cost effective. So these three different dimensions. So the production is one thing, privacy is one thing, and accuracy of the results, whether a person is being affected from dementia or not, or maybe at a very early stage, or maybe in the beginning of the year, that person is not at all a patient, but maybe later in the years, that person is a patient. That kind of accuracy is possible only when we have an automated environment for dementia affected people. So this was one thing. Another, what can be done in future is that where we are providing smart environments, where we are helping people who are diagnosed with the problem. So the people who are diagnosed with the problem, providing them the smart environment, and that can be done again within the close premises, within the close vicinity of that patient, and within the indoors of our homes, and where we can see whether the person is okay, if that person is moving or not moving, or maybe what area that person is going. Maybe that person is forgetting something. So some applications are actually making that person aware, okay, you have to do this, you have to do that, you have to pick something from here, maybe from the first cupboard or maybe from the last drawer. These kind of environments is going to again help people with very maybe mild or moderate dementia, who are not that vulnerable, who can take care of themselves by these smart environments. And this smart environment is only possible if we are implementing the variables. It will be a combination of a variable, and it will be a combination of indoor positioning systems. Why am I saying that indoor positioning system is important? Because I am taking this as a presumption. You may correct me if I'm wrong. So I'm assuming that indoor positioning system is important for them, because once a person is suffering from dementia and already on medication, the person might forget to take the medicine also, might forget to do their daily simple thing, maybe combing hair, maybe brushing their teeth. They can forget even the minutest and the smallest and the very basic details of their life. I'm sorry. So this is very important for them. So these are 2 areas where the researchers can work now. So, okay, so one more thing I wanted to show you. I'll share my screen one more time. I hope this is visible.
Yes, it is.
Okay, great. Thank you for confirming.
Yeah.
So this was the this was the current paper which was published on the results which we were talking about, what we were discussing till now. So LPIML model, it is based on prediction of dementia in young adults. The data set was derived from GitHub. This was for experimentation purpose, and the entire implementation was done on Google Colabs. Then, okay, the model, the mathematical model that I was talking about, and I wanted to discuss this, that where we are considering the patient individually, and we are taking the data where MRIs are collected. And we are creating a repository for the patient, and we are creating it from the day 0. So you can say that even if the person is not a patient, then also we are keeping the repository of that patient. Okay, what were the brain MRI scans were, what was the positioning, and how bad it was and how good it is. So that was first thing. Then we are talking about each time that person is visiting the clinic and multiple MRI scans are taken. These scans are kept in a repository for each patient. And this is taken from across all diagnostic centers. So it was not like that. The model, the mathematical model was about, okay, not one diagnostic center, or maybe not one reports, but set of all diagnostic centers where that person may go. It can be outsourced, it can be within the hospital, it can be a nearby place to that patient. What all scans have been done, that was taken care of. And then that was taken into account to judge whether what is the stage, what is the initial stage. So initial phase, we are just scanning the images, we are resizing the images, and we are obtaining the morphological enhanced images. This was one thing. Then taking the points on the MRI for plotting these instances, adding the Gaussian noise in it so that we can understand, providing weights to the distance of each point assessed using simple linear models. It was a simple implementation which was done just to identify the progression of dementia. And in step 2, or you can say in algorithm 2, once we are done with all those scans, we are having that repository intact, then we can come to the morphological altered images and then start evaluating using the local post-hoc interpretable machine learning model to create the confusion matrix. So these were the 3 observation cycles which were taken. First observation cycle, loading the data sets, then applying the morphological operator with segmentation image, and then getting the enhanced image set, and then applying it with the data set that we have, and applying it on different data sets. Like we have got 3 data sets. So first one was used for training, second and third was used for testing. Then the combination of these 3, like second one was taken for training, the first and third was taken for testing. Then the third cycle, we were talking about the third data set took as a training data set, and second and first were taken as a testing data set. So this was applied, and then we initialized the entire data on local post-hoc interpretable and creating the confusion matrix. That confusion matrix was dependent on the sensitivity, precision, the evaluating the F1 score, and repeating this entire cycle for the next 2. So this was done on almost 1,279 images, and total 179 subjects were diagnosed with mild dementia, and 12 were diagnosed with moderate dementia, and 448 were diagnosed with very mild dementia, and 640 subjects were not demented. So the idea was, okay, the people who are not demented or maybe are not in that stage, not suffering from dementia, their data set should also be kept in repository for future, for maybe after 2 years, after 3 years, maybe after 30 years also, if we want to see whether what was the progression, whether there was a problem or not a problem, and that kind of research can be done. Then the unique values which were taken, each subject has been scanned at least twice within a gap of 1 year. And most of the people who were part of the data set were right-handed. They were right-handed people, like men and women both. And this was the data taken, and the results were understood that how it is happening. The split of that entire data set was into 80% and 20%. So 80% was kept for training data set and 20% was kept for testing the data set. But this can be improved. This can be improved and this can be randomized also. So it is not like that only 80% has to be kept or 60 or 40% has to be kept. This can be randomized to understand the efficacy of the model. So this was one thing I wanted to share with all of you. And if we see the type of images that we get, so this is simple MRI scan. You can see it is black and white and gray parts. And this is one MRI scan where there is no suffering. Another MRI scan, you can see there is a slight suffering, very mild one. This we, as a faculty of computer science, computer application, we don't understand the MRI scans. We don't understand these images so good, but these were the images taken from the existing data set where they were classified that, okay, this kind of an image is non-demented. This one kind of an image is with a very mild dementia, and then another one is very mild, and the images were there that they are suffering from dementia. So what I understood from these images was that the gray matter is the less gray matter or the less white region we can see, that means that the person is suffering from dementia. So these were the 4 classifications taken as a image, just a sample images in the data set. And these were the observation cycles. We got sensitivity, specificity, precision, recall, FN measure, and DICE. These was for the 3. This was done for both. It was done for original images also, and it was also done for morphologically enhanced images. And segmentation was used to get the results. So these are the graphs that we have plotted for our data set. And what can be done next? I told you that yes, it has to be an automated environment. It has to have that automated environment for people who are suffering and the variables for people who are not suffering and who want to actually self-diagnose. This is very important because these kind of diseases, it is very difficult to keep a track of the patient. This is one thing. All family members, they are very much affected with the disease. This is another thing. And getting them treated, getting them diagnosed, and getting them medicated, and I can say, and checking the progression of the disease or the patient or improvement is very difficult. So why am I saying this with so much of confidence that yes, it is difficult? Because I have seen that in families. I have interviewed, you can say, I have interacted with few families who are having people with dementia in their family, and they have a big concern. And they are, the other factor which is important is that they also do not know whether what is to be done, and they are also vulnerable. The same way the patient is vulnerable, patient doesn't know whether that person is affected, but everybody knows that the person is affected or their near dear ones are affected, and both of them do not know what is to be done. So for them, it is going to be a huge help where they can actually diagnose at early stage, treat it, check the progress, and keep track of the patient. And dementia is only one maybe we are just, you may take it as that dementia, we are thinking of dementia as only memory loss, but it is not only memory loss. It can be schizophrenic also. It can be difficult. It can be, if that goes to a stage of schizophrenia, then it is going to be very difficult for the patient as well as for the people who are trying to treat them, and even the doctors, even the relatives, near dear people who are there staying with them. It is very difficult. So this is a very concerning area where we all need to, if any one of you is interested working in, we all need to focus more and can come up with a better solution with the help of course, AI. Another area where this is where more things can be done. Another area here is that where we are applying explainable AI models, where we can actually see that why this result has come. If the AI model is saying, okay, a person is at a very early stage of dementia or is suffering from mild dementia, then why that model has come up with this kind of interpretation, that applicability, that explainability can be applied, that can be done with the help of explainable AI. So this can be another area we can do more and more work and research on this. So this was something which I wanted to share with all of you. And again, I'm sharing my slides here. So okay. I hope this is visible again, my slides.
Yes, it is.
Okay, great. So this was the last segment where I wanted to talk about what can be done in future. This is something being done already. Many papers you will find, many research you will find, which is more focused on medical side. You will find blood tests, you will find you will also find smell technology, where we are talking about that, okay, with the help of smell technology, we can also identify diseases. So even that can be applied here also. So these are some future research areas in dementia for their early detection. And this is me. I'm Vandana Sharma, currently working as a postdoc fellow at Lincoln University College, Malaysia. So this was my postdoc topic. So, and I did it with another author. She's my guide, Dr. Divya Midhun Chakravarti. And thank you everyone for giving me time. And now I'm open for questions if you have any, and any suggestions also, if you have any. Thank you so much.
All right. Thank you so much, Dr. Vandana, for that very insightful presentation on cracking the code. All right. So everyone, if you've got questions or anyone who's got questions for her at this point in time, you could just signify by raising your hands, or you could drop the questions in the chat box, then we could read it out to Dr. Vandana. So she's open for questions at this point in time.
There's one question already in the chat box.
Yes, there is one question. I'll take it. It's, can a vector database improve the automotive environment and reduce the process challenges with likely repeat experiment in this area? Why not? Yes, very much. It can be. And I think this can be a very good input for the research that can be done. Yes, it is going to reduce the process of if we are taking care of the vector databases, definitely it can. And we can have various measures also. The proximity is one measure. Repeated cycles or maybe repeated instances is another measure. This can be taken. I hope I have answered your question.
I wanted to find out, is dementia hereditary?
Yes, Professor. There are 3 classifications for dementia. One is hereditary. One is related to accidents, like if a person has met some accident, so that might cause dementia. And the third one is also temporary dementia, when a person is into the influence of substances, then also dementia happens. So that is one temporary, one is based on hereditary, and the third one is the accidental. Yes. Okay, so another question, did you encounter any legal and ethical challenges with access and use of medical data in this experiment? Okay, so the data that I have used is available openly. It is available on open repository on GitHub. So for that matter, I did not have to take any permissions. So there was none. But what you are asking is very right. So if I have to work on real data sets and of real patients, then definitely I'll be facing the legal and ethical challenges. That is one challenge we all researchers are facing. So if we are not from the medical background and we do not have a direct access to the primary data set, then definitely we have to work on only the secondary data sets which are available openly on public repository. So for me, there was no challenge, but yes, if I want to improvise, if I want to dig deep into this, and if I want to come up with the environment, the smart environments, definitely, then it will be a challenge.
And if I could just sort of interject there, presumably then that's when, I mean, Dr. Celestine always refers to the absolute significance of collaborative research, and presumably it's in those spaces where it's so important for you to be working alongside medics and clinical practitioners,
Yes.
so you can get to that very current data.
That's right. That can be done in collaboration, but then there's a problem of privacy. There's a problem of privacy. It is not that easy. Even if we are collaborating with the medical practitioners, even if we are close friends with them, even if they are part of our research, it is very difficult to take the real data from the primary sources and take the permission and then put it into a research area and put it into the papers and put it into a public repository. Because once you go for research, you have to share the data set. Only then you can say, okay, this was my data set, and based on this data set, I have come up with this conclusion. So that sharing of data set, again, if it is from the primary sources, it is going to face legalities and ethical challenges. So this is one major concern.
I'm just looking at using scan images and using sensors, to dictate what happens in the brain. Which one will be much more better off to use?
For scanned images, and what was the other option we have?
Sensors.
Okay. So scanned images and sensors. So sensors will give you biomarkers. That is also very important. And it is going to give you real-time biomarkers. Very important. And the MRI scans, because we are talking about brain. So brain is an area closed. We need scans. So we can combine both of them. It is not like that only MRI will work or only biomarkers will work. Are you getting my point here? So we need both of them. We need a mix of, we need clinical study also. We need clinical reports also. We need medical practitioner insights also, whether the patient is, so clinically trial and error, what happens in a long span of time, maybe 1 year or 2 years, that can be like limited, that can be reduced with the help of including the biomarkers which are gathered from wearables, plus the MRI scans. Because every time you can't go for an MRI scans, but every time you are having those biomarkers with you.
Any more questions, please? Okay, so while we're waiting, Dr. Vandana, I would just want to ask something. While you were presenting, you made mention of self-diagnosis. And
okay,
so my
yes,
question,
yes, I have.
So my question would be, could you just share a little more light about self-diagnosis? Usually we know these processes has to do with having to go for scans.
Yes.
And Dr. Celestine was talking about sensors, but usually it's more of scans. So if people would have to self-diagnose themselves, what are the methods? And can we now have a scenario where they can, there are tools that people can use to self-diagnose and feed into the models that would help to be able to early detect such cases as dementia?
Yes, of course you can. So even now, if you just try to search for a self-diagnosed test for dementia, it is available. Also, when we talk about dementia, a typical test which is taken by any medical practitioner is pen paper test. They'll show you certain images, they'll ask you to draw a clock. It will be difficult for a person who is suffering from dementia to draw a simple clock with two hands. So this is something which is there. So there is a pen paper test available that will be taken, or that can be done with in presence of a medical practitioner. Also, there are diagnosis tests which are available online. It will be comprising of certain images, some questions. Maybe you are in a position to recall them or not, whether you're in a position to answer them or not. Are you able to understand the language, simple language of the text? Are you able to interpret it correctly? Yes, it is there available. But the major drawback of these self-diagnosis tests related to dementia, I'm saying, they all are working in isolation. So the same test which can be done in pen paper, the same test is taken online. So there is one. So there is one application for pen paper. There's one application there as a questionnaire, where you are just answering certain questions. There is another application where they are talking about a clock draw test, where you have to draw the clock, or maybe you have to write something, because once the progression of dementia happens, it will be difficult to write also. The writing will be very deformative. It will be difficult to recall. It will be difficult to judge. It will be difficult to infer. So there will be many things which will be happening simultaneously. But the self-diagnosis, what we have as of right now, is working in isolation. Small tests which are available online. What we can do is, for self-diagnosis, we can have a device with us. That device, maybe it can be a wearable, or kind of like a wristwatch. It can be a neck band. It can be a small application running on your phone, taking care of the biomarkers also, doing certain scans time to time, doing maybe keeping a journal kind of a thing, maybe trying to do all these set of tests in one place. So that can be like a self-diagnosis, whether are you progressing towards this disease or not. That kind of thing can be possible, but it is not there right now.
Okay. Thank you very much. Yeah.
I'm also thinking of, as you are speaking now, looking at our department where we are delving into robotics application, especially the medical area. So I'm looking at a possibility where our robotic group can be looking at research on this, in terms of having programming the daily activities. Remember, based on AI, programming, using AI to program daily activities and have a robot to assist dementia patients.
Yes, it can be done. So that is what I'm saying, that nowadays we are having one robotic application. You must have seen that while waiting for a restaurant, maybe you're waiting for a table for two outside a restaurant, and then there is a robot who is actually escorting you to the right table. This is something which is additional, maybe not required. This is very fancy, but for a person who is suffering from dementia, it is a need. It is a necessity for them to somebody can actually help them sit somewhere, eat something, take their medication. Maybe if they want to prepare a simple boiled eggs, so somebody is actually telling them, okay, take a pan, take some water from tap, half, take 2 eggs, 2 are sufficient for you, boil them, let the gas. So these are something which are very much needed. So what can be done is you can come up with the copyright with very small processes which are needed, a very small set of modules which are needed for any person who is affected from dementia. Then you can talk about the patents, the actual products, or maybe some devices where we are actually helping them, and maybe simple locating, I'm not getting the right word here, locating things for them. A very simple thing, maybe just a glass of water, locating there, where's the glass, where's the water, that kind of thing. Maybe they want to prepare something for themselves, so locating the shelf, locating spices, locating sugar, tea. So this is something that can be done with the help of simple, small implementations. Maybe with the help of BLE tags, this can be done. So this is one patent idea can be done. And then the futuristic problems like, okay, you're coming up with a complete 360-degree solution for them, having a smart environment, having diagnosis, checking the progression of the disease, checking the progression of the patient. Everything can be done. Like there can be so many things that can be done only in this area. So I hope I have. Thank you. Thank you so much.
Yes. So we will not have. Okay.
There's one more, I think.
All right, Sam, go ahead, please.
Yes, I'm fascinated, and in some ways it might be a sort of clinical question and beyond the remit of the discussion, really. But I mean, the paper that has just been published, you're focusing specifically upon diagnosing dementia in juveniles, in adolescents. What kind of differentials are there? Could you say that? I mean, it's fascinating because obviously many of us will be able to identify dementia as a ever-growing issue for the aging population, but I think many of us may not be fully aware of that sort of early onset dementia.
Yes.
I mean, do they manifest different? Does dementia manifest differently in different age groups? I suppose is the question I'm asking.
Yes, it is manifested. Yes, very much. After COVID, you must be reading many things about brain fog. So brain fog is something when I'm talking about a subject here, and the moment I speak about subject X, I forget about the next moment. I was talking about X. I will take a moment to think, okay, whether it was X or something else. So this is what brain fog is. So how this has happened? This has happened with the medication, maybe because of the we really do not know what was the reason behind it. So yes, it is happening in young people also. And if you see the engagement of people nowadays on social media, and the engagement of them and they are all in isolation mentally. They are not social, actually. It is very contradictory to say this, but they are not social, being on social media. So they are isolated completely. They are in a different world, virtually, in virtual spaces, and they tend to forget what is happening in real life. And that actually affects them. It affects their memory span, their attention span. So there was a recent study where we see that the attention span was not even of 5 minutes. Nowadays, it is not even 5 minutes. The attention span I'm talking about only.
That's
So
fascinating.
yes, yeah, it is there. So we need to see, okay, if I am or maybe my son, or maybe somebody in my family, even anyone, any near or dear one, wants to self-diagnose first whether, okay, is this a problem with me? Is this something that I have to take care on myself, maybe before declaring it, or maybe somebody telling me that, okay, you are suffering from dementia? So it will be very good now. It will be good for all of us. We can go with flow, progression of the disease. Maybe we can go with certain medication, maybe some kind of mental exercises or test, or maybe taking care of ourselves, reducing the virtual spaces or maybe virtual time that we are in today, limitlessly.
Thank you.
All right.
Thank
So
you.
just to add to what Sam said, during the early part of your presentation, you talked about some tens of millions. I think about 55 or 65 million
55,
people.
yes.
55 million, and also that is the 7th out of 10 causes of death,
Yes.
with an over 60% of fatality. So
Yes.
for people who contract that. So if this research, I feel it's more like a novel one, and since if we can effectively break and crack this code, the impact on the society is going to be enormous.
Yes.
All right, so I was just trying to look at the connection between this and what I think there's a similar project that Elon Musk is working on, the owner of Tesla. It's called the Neuralinks. So he's working on a possibility of, but he's targeting schizophrenia and autism. All right, so it's looking at how they could have implants that would help to send certain kinds of triggers to the brain or the central nervous system that would be able to correct that form of anomaly. All right, which will create stability in the person. So if part of this research and analysis of the various scans it's possible to be able to detect where the anomalies are. So I think a possible project like that, where there will be maybe implants or certain things that would send the sensors back into the brain, will be able to create that form of stability also in this kind of challenge. What do you think?
Yes, Bilkul, absolutely. Absolutely. This is what I was talking about. I was talking about biomarkers along with the sensors, wearable ones. Maybe it can be in a form of a jacket, or maybe it can be implants also. Because we are heading towards a technology, we don't have to, we actually don't have to be the wearables. We don't even have to have a wearable. We can have an implant for this. And to add this, there's one more step can be done. There was one study I was coming across. It was regarding Parkinson disease. So there was one lady, I'm just quoting here, that there was one lady, she was a nurse. And that lady, husband was suffering from Parkinson. And there was a very different smell which comes from maybe from patients who are suffering from Parkinson. So she was treating people, or maybe she was taking care of, as a nurse, she was taking care of people who were suffering from Parkinson, and she also detected the same smell from her spouse, her husband. And she was able to say, okay, see, maybe you may have this disease, and this is something which is progressing with you, and you must get yourself tested. And yes, the tests were positive. Those tests were positive. Can you imagine that? This was something very, very, what should I say, breakthrough it was, that with the smell also you can diagnose. So if we can apply smell technology along with these set of biomarkers, variables, we can have multifold results.
Thank you.
Thank you. Thank you so much.
Adrian.
Thank you so much, Professor Celestine, for giving me this opportunity. I completely enjoyed the conversation. Thank you.
We'll hand over now to Sam.
Yeah.
Okay, if I can share screen, if that's okay.
Yeah, please. I'm just stopping my, yeah. Yes, you can now.
That's lovely. So this is just to say a huge thank you to you, Dr. Sharma, for sharing your time with us. You'll see you've got your e-award there. And, you know, we are so proud to be hearing the fantastic, I mean, this is hugely significant work. And, you know, it's very rewarding to hear about the steps that are being taken forward globally, but also, I mean, it's very interesting to hear potential collaborative opportunities where perhaps colleagues in our department could be working with yourself and other colleagues on the other side of the world to take strides forward in this very, very, very significant area for all of us. It's such a huge global challenge, and it's fascinating to think that technology can help us so much in this area. So so there's your award, and then I'll stop sharing it. I'm sure Dr. Celestine will forward it on to you, which you'll be able to treasure forever and ever this evening. And it's just to say a huge thank you, Dr. Sharma. I'm sure everyone would agree that's a very, very interesting, very important topic, and one that I think will provoke thought and conversation going forward amongst ourselves. I'm sure, you know, I know myself, I will be sharing this information with friends and family, because there's so much, you know, the more we can spread this word about the things that can be done, but also how we need to be aware of certain manifestations of dementia. I think it's so valuable. So thank you so very much. And thank you as ever to our hosts for looking after us this evening, and for Dr. Celestine for setting this up, I mean, and our guests, our fabulous students. So thank you once again, everyone, for a fantastic November to remember. But perhaps a round of applause for Dr. Sharma. I think that was a fantastic talk.
Thank you.
Thank you very much.
Thank you so much. You have been very kind and generous in your comments. And I completely enjoyed, and I look forward for collaboration. I look forward to work. This is not the end for me. Thank you so much.
Thank you, everyone. Thank you, everyone.
Thank you, everyone.
Thank you, Ma.
For entrepreneurial time. Invite others for a very big time tomorrow on entrepreneurial empowerment. It will be very great with Dr. Sadiq. Thank you and good night.
Good night.
Good night. Good night.